So, this thing's running a little bit warmer than I would like to see it. Um, a few folks on the Vintage Six forum on Facebook have I've already talked to some folks about it. There's a lot of opinions on this. Um, I wanted to keep the stock setup. It's got the 4-blade fan in it. It's a 3-core replacement radiator. I'm not sure if it had a 2-core in it originally. It is a brass copper radiator. It's what was in it when I bought it, but it's brand new. I'm not going to change it, and I'm going to tell you why I'm not going to change it to an aluminum radiator, which I would have preferred anyways. Actually, it was like the same price. I don't even know why they put this in here. Probably because, if I had to guess, it's probably the spacing, because the aluminum core is thicker. The aluminum radiators do have more capacity, and the reason for that is because the tubes in aluminum radiators are larger. You can have a larger tube because they're stronger. You can't do a large tube like that in a copper or brass radiator. They will crack. That's the main difference. Fatter tubes are better. You get more cooling capacity that way. But since it's bigger, it won't fit with the fan. Now, because this is not a shrouded fan, this is the way these things are set up from the factory. It's very close to the radiator. That's the only way that it's going to work without a shroud. I thought about putting a shroud on it. They don't make one. There is one that's sort of will fit, but you have to do a bunch of things to make it fit. I'm just going to abandon all that. I was going to change to a different fan, and the spacing's wrong, and it's going to hit stuff, and I've got power steering, so it was going to hit the pulley down there. I'll explain why I think, and this is going to be my opinion, but it's based on some knowledge that I have about radiators. My theory is that, because there's some folks saying, well, that 4-blade fan works fine in my car. Well, something that they started doing with these radiators, well, first of all, this is a 3-core. And if it was a 2-core originally, the radiator had less static pressure. This, and I've covered this before in another video that I did about cooling systems. The thicker a radiator is, the more static pressure it has. So like a 4-core radiator like the one in my 69 Chevy that I've got, that's probably got, I don't know, 15 millimeters of mercury or 15 millimeters of water column. That's quite a bit of static pressure. So more static pressure, you need more pulling power from the fan. In the electric fan world, that constitutes the need for more torque. You have to be able to pull through the resistance of a radiator. Now, typically a large fan like this is going to be able to do that, but it's only 4 blades, so it's kind of limited on what it can do. I think that these replacement radiators, they have higher static pressure, and it's because the fins are more tightly packed than they used to be, and it's a 3-core. So it's not going to draw near as much air through at idle as it would a thinner radiator. So it's kind of counterintuitive, but if the radiator were to have only 2 cores instead of 3, it would probably cool better at idle. But you would sacrifice capacity at speed. So when you're generating more heat, like when it's running at 3,000 RPM on the freeway, if you only had a 2-core, it actually might overheat while you have plenty of air coming through it, but not enough cooling capacity to the radiator. My theory here is that there is plenty of cooling capacity here with this radiator. I can drive at 25 miles an hour around the neighborhood, and it's 80 degrees outside, and it stays, right around 185, 190. The second I start sitting at stoplights, it starts coming up, goes up to about 205. As soon as I start cruising again, it starts backing right off. I conducted a little experiment yesterday, drove it around, got it pretty hot, kind of slow around the neighborhood, backed into the driveway, and I took a blower fan and I just pointed it at the front of the car, and with the hood closed, sitting there idling, and the temperature started coming down within a minute. It was down, it went from 208 or so down to 197 just from a blower kind of pointed at the front of it, from a ways back, not real high capacity. So I immediately know that it's an airflow issue. It's not a radiator capacity problem. There's no other issues with this system. I mean, the engine's fresh rebuilt, no issues there. It's not overheating at speed. It's got a new radiator and a new heater core in it. new thermostat. It's none of those kind of typical things that can cause, because there's different kinds of overheating. There's overheating, when you're driving on the freeway, but not at idle, or there's overheating at idle, or in stop and go, but not as soon as you pick up speed. I can definitely tell by the fact that this thing cools down as soon as it gets airflow, and I can tell by the amount of airflow when I feel in the front of it. It's very low with this fan. We're just not pulling enough air through it. So I'm going to go ahead and try a electric fan on here. I'm very familiar with doing electric fans, but the challenge with electric fans is, just like I said, you need more torque the more static pressure you have. In order to get more torque, you need a larger electric motor. Larger DC motors tend to put out more torque the more current they pull. That's a really good metric for an electric fan. If it pulls 8 amps, it's probably not pulling a lot of CFM. If it's pulling 25 amps, it's probably pulling a lot of CFM. It's not all entirely just diameter of the fan, and that's important too, because having coverage, you want to have as much coverage of your core as possible. But in general, you need a larger motor. Well, there's no room in here. There's like 2 inches. Basically, there's like 2 inches to play with. There's about 2 1/4, but that's about as close as you want to get to the front of the water pump. So I'm going to be very limited at the fan that I can put in here. I found a Spall. Spall makes probably the best fans that are out there. I'm going to go ahead and I'm going to pop a Spall in here that's about 1300 CFM. That's a little on the low side, I think. However, I guarantee that this fan at idle is not pulling 1300 CFM. So we're going to give it a shot. I asked a few other folks. I had one person reply that's in LA like I am, and he said he's running the Spall 1300 CFM fan and it works great. It solved his problem. I'm thinking it'll do the same here. The second option that I can do here is to put a pusher on the front. A lot of people do that because there is more room down in here for a pusher. Here's a problem with pushers. They don't work as well, first of all, because just like if you're trying to push a cart versus pulling a cart, you all know that pulling it is going to be a whole lot easier than pushing it. It works the same way with air. The same dynamics apply. Physics don't change. The other thing that happens is when you're ramming air through the front here and there's an electric fan on the back side, there's a gap between the motor and the air actually has a chance to escape around it. When you have a motor on the front, you've just blocked that big circle of the front of the core of the radiator. And you will not be forcing air through that part of the core. They do work. There's a lot of folks that are using pushers. I think if you use a pusher and the mechanical fan, that's probably a good option. I could go that way, but I'm not going to. If I'm going to get rid of this fan, I'm going to get rid of it. Already solid fans are hard on the water pump bearing. They don't work that well unless they're set up really properly with a shroud. If I'm going to go electric, I might as well do it right. So I'll get that thing out of there. I'll gain a little bit of space in here too. I'm going to take the smog pulley off of here that I don't need anymore anyways. It's on there because I needed the spacing for this fan. But I'm going to take that off and gain as much room back as I can. I'm just going to put a single 16-inch Spall 1300 CFM fan on here. We're going to see how that runs. I suspect it's going to solve my problem. So I'm just waiting for the parts to come. But as soon as they get here, we'll go ahead and cover the install of that, and I'll explain how I'm going to set up the wiring for it. I've got a 75 amp alternator on here that was a direct replacement for the original 55 amp. I ordered a 100 amp alternator. I might be able to get away with this, but it's going to be really tight on power budget. So I'm going to probably have to swap it out, which means I got to go to a one wire, which means disconnecting the voltage regulator. And of course I've got to add relays for the fan. Well, I'm actually going to add 2 relays, and I'll cover in the part of the video when I install that why I'm going to run 2, because one's a pilot for a larger relay. And I'll be driving it with the outputs that are available on the Sniper EFI. So the Sniper EFI down there, there's a pigtail that comes off the back of it, and it's got a couple of outputs. I can use it. It'll actually use the temperature that it detects with the temperature sending unit that's in it. That will trigger the electric fan relay for me on and off. And it's fully adjustable that way. I don't have to put a thermo switch in or anything like that. Fuel injection will do it for me. So that's kind of slick. So we're going to go ahead and we'll get that installed, and we'll see how it goes. So that's just a little blurb on what I think is going on with this cooling system. So in part 2 or maybe the second segment, maybe I'll do this all in one video. I'll go over install that and we'll see how well it works. Okay, so we got some movie magic going on here. Everything's installed. This is actually the third fan that I made the decision on. The previous video, I would go check that out. I talk about performance curves for electric fans. That's very important because different fans have different performance curves, and certain fans may have a lower free flow CFM rate, which is what they're all rated at. They may have a lower free flow rate, but they actually will pull more CFM under higher static pressure than some other fan that's got a higher free flow rate. That's very important that you look at the performance curves. I actually shot a segment of this with the other fan that I ended up putting on here, the FAZ fan that I talked about in the other video. I installed that fan. It actually worked fine. And then I was talking to somebody on a Facebook forum, and he mentioned the SPAL 1516, which is a medium profile, the next step up from the other SPAL fan, the 1300 CFM fan. I looked at the performance curve on this fan, and the performance curve is so much better on it for, the 3/16 of an inch thicker that it is. And I started really looking at the dimensions here, and I said, boy, if I change out to a low profile socket head cap screw on the water pump and I offset the fan a little bit, I can make it fit. And it does fit, and it is tight. I mean, there's 1/8 of an inch there, but it's enough. I tested it out, and you can see how tight it is here. No problems. Even with heat expansion, there's still a good enough gap. I got it nice and hot the other day, left the hood down yesterday, and there's no problem. There's no problem. It's mounted solid on here. Use these good brackets always. Don't use the ones that go through the radiator. Copper radiator will actually cause it to crack. Aluminum, you can kind of get away with those. I don't like using them. So this fan's, I want to say it's rated around 13 or 15 amps, something like that. The other fan was rated right around 8. It was working. It was fine. It was definitely keeping up, but it's also not hot out right now. It's 70, it's in the low 70s or so. I'm thinking about the days where it's 100 out here in LA, and I want to be able to drive this. Not that I will. Who knows? I want to be able to if I want. I don't want to have any cooling issues. This thing is moving so much more air than the FAZ was. I can just empirically kind of tell by putting my hand in front of it. I mean, it's definitely, the performance curve matches what they say. This moves, I want to say, with the static pressure. I'm assuming this radiator's got about 12.5 millimeters of static pressure. So, right around 1/2 inch is water column static pressure. So this fan will move 1,000 CFM with that static pressure. The fan that is slightly narrower, the FAZ fan that's slightly narrower, that gives you a little bit more space, only moves 400 CFM at that static pressure. That's why performance curves are important. So definitely look up the performance curves. The only fan brands that I know of that they actually give it to you is SPAL, and this new one that I found, FAZ. You have to look at the performance curves of the fans. I can't say that enough. Got the Summit 100 amp alternator on here. It has no problems putting out the current that I need between my fuel injection and the fan running. And all my lighting's LED now, which also helps a lot on budget. By the way, if you're interested in that, look up Octane Lighting. I've got a video on that on their LED HID headlights. They're great. Save some budget there, but this thing's at 14.5 volts with the fan blowing full speed. I turned the headlights on and the heater blower and had the fan running and had everything on, and I was still at 14.5 volts, so there's no problem there. Went against all of my rules here. I didn't use a variable speed controller. I didn't use a solid state relay. Those are all things that I always tell people to do. Budget build to get a proper variable speed controller that has the right PWM rate. you know, it costs money. I don't want to spend it on this. This fan's only 15 amps. The relay here is rated for 40. The normally open side of it's rated for 40. These are rated for like 250,000 cycles. So if you drove it every day, this relay'd probably last you like 6 years, assuming that it doesn't prematurely fail, which they do occasionally. I don't like using them. They have moving parts in them. They do corrode. The contacts do burn up. This one's from Painless. It's a pretty good relay. It's got a flyback diode built into it already. If you're interested in what a flyback diode is, I've got a video on that somewhere down below in all of my videos. Look it up. It's got a circuit breaker. This was just like a Painless, you know, $20 or $30 kit. You know, it came with the socketed relay, you know, which is nice. You know, you can just swap it out. I carry spares of these when I do run these because if it dies, I can just pop a new one in. Same for the fuel pump for the fuel injection. It's the same one. It's got a circuit breaker. This is a 40 amp circuit breaker, I think, which is a little bit high. The wire is 12 gauge, so I'm actually not protecting it correctly. Like I said, I'm breaking all of my own rules. But they're short distance runs. I'm not really worried about it. It'll be fine. If you get a dead short, this thing's going to open up right away anyways. I'm not worried about overloading it with this fan. That wire's not going to melt at 40 amps. So, you know, kind of went cheap on that, you know, solid state. Go that route if you can. Variable speed would be nice with this fan since it's a little bit higher flow, because what's happening right now is it works so well. It gets up to, right now I'm conservative on my numbers, so I have it turn on at 195, turn off at 190. It's swinging every minute, or well, it not every minute. It heats up in about 2 or 3 minutes, gets up to 195, the fan kicks on and it cools it off so quickly it comes down, and like I timed it, it's like 1 minute and 4 seconds. It goes from 190, and it with like a 75 ambient outside, goes down to 190 in 1 minute and 4 seconds. So variable speed is nice because it'll give you a consistent temperature. So I may end up replacing this, but you know what, it's fine for right now. You know, temperature swings are not great, but it's, you know, a lot of people run them like this. So I ended up not using the continuous duty golf cart relay that I normally would use in something like this. If this fan was pulling 30 amps, that's what I would do. But it's not. They do make much heavier duty relays. There's a company out there, White Rogers, their big industrial name. They make those continuous duty relays. They kind of look like Ford starter solenoids. They kind of look like these a little bit. They're just a much heavier duty relay. They have a high cycle count on them. They're just rated for a little bit more beating. At 15 amps for 40 amp relay, this thing will last decently. So, you know, don't think that you can't do it this way. I just prefer to not do it this way. I really like high reliability systems, and high reliability systems include no moving parts. So that's just kind of an overview on how this install went. It's working great. I need a hot day before I can give you guys a judge of how well this works, but this fan moves plenty of air. Like I said, I ran it for a few days with the FAZ fan, and it had no problem keeping it cool. I drove it a decent amount. I just got paranoid, and I found out that I could fit this fan in here. I said, I want more. You know, it's just like the guy's got plenty of horsepower, but he wants even more. It's same thing here. So, you know, higher performance fan is better, especially here in LA. It frequently gets into the hundreds during the summer. So, all right. That should just about cover it. I might do a follow-up video where I let it heat up and I show you guys how quick, you know, it cools down, or how well it works when we actually get a warmer day. It's just not going to be warm here for a while. So, anyways, we'll wrap this one up. That's the electric fan install. Yes, the SPAL 1516 will fit if you've got a i6. It's just really tight. Low profile bolts I got from McMaster-Carr. So everything seems to fit real well.